want to welcome you to another video at the redoxdoc.com video course series. This topic today is on hormone issues as they pertain to our redox chemistry and our overall health. And in particular, there are many kinds of hormones in the body of all different kinds, blood pressure hormones, etc. We're going to focus on the sex hormones today: estrogen, progesterone, testosterone, and DHEA. They're all very similar. They are all made from cholesterol in the body, and in the bloodstream they float unless they're bound to proteins. So these all have a similar molecular picture, but they have different jobs. So we can talk about them together. So our brain and our hormones are very much related, and there's sort of a feedback loop that exists. So the pituitary gland in the brain and the hypothalamus in the deep part of our brain are paying attention to the body's needs. And so they are involved in the production of hormones from our ovaries and testicles. The ovaries produce estrogen, progesterone. The testicle produces testosterone. And our adrenal glands play a role as a backup organ in the production of these, but they're not the primary source. In the testicle, the cells that are producing testosterone are called the Leydig cells. And the fact is, as we have measured in men over the years, about after the age of 40, there's a 3% decline in the amount of testosterone produced in the average person each year. So by the time men are in their 50s and 60s, they've usually crossed a critical point where the amount of hormone that can be just produced is diminished. So if there's plenty of hormones being produced, the brain senses that and it sends a message, okay, we're going to cut down production a little bit because there's plenty. If there's too little, the brain says, okay, we'll get you some more. This is a common thermostat feedback loop that exists in our overall physiology. Later on, we'll talk about at the cell level, it's a little different. So most of the problems about hormone issues revolve around imbalance or decline. And in a way, that's the same thing. In our younger years, once in a while, especially in women, progesterone and estrogen are out of balance, and that can create problems for the estrogen receptor organs like the breast or the uterus. There can be uterine tumors, there can be breast cysts, things like that, if those are out of balance. The reasons for that oftentimes are genetic, but it can be related to our diet. So if we just take it down to a cell level, I think it'll be helpful to show you how at the very cell level, the ability of a cell to produce hormones is really critical in making this whole thing work. Because if these end organs can't listen to and do what the pituitary is saying, it doesn't matter how much of a need there is, it ain't going to get done because it can't be produced. And those cells may just sit there and look nice, but not be able to do their work. So let's look at an ovary cell. And in that cell, it's a typical cell. There's a cell wall, there's a nucleus, and there are little mitochondria, the powerhouse of the cell that's involved in doing many things. But they're very critical in helping with estrogen synthesis. So they themselves don't make the estrogen, the cell does. But the cell will not do that work unless the mitochondria is creating a healthy environment in the cell. How does it do that? The mitochondria are the internal organ that helps the cell breathe. It's called cellular respiration. So the mitochondria takes food, nutrition, oxygen, things like that, and converts that into energy. That energy is needed for the cell to do its work. Without it, it won't. It also helps the cell maintain a balance of redox chemicals. These are molecules that are critical in allowing the cell to do its work, to help the antioxidants detoxify the cell, to help the nucleus stay in balance, to help get nutrition in, waste products out of the cell. All of that revolves around redox balance. So if the cell is healthy, it's going to synthesize estrogen. that estrogen molecule is going to be floating around nearby and actually give feedback to the cell at the mitochondrial level and at the nucleus level to promote further production. So it's like you make some and it promotes making a little more. So it's a positive feedback loop instead of a negative one. It's very interesting. In fact, nuclear respiratory factor 1 in the nucleus of an estrogen cell is literally switched on, allowing for better production of more estrogen. So the more you have, the more you get. It's kind of cool. So not only our overall health, but sometimes we have the ability of these cells to live longer and be more productive when we have a healthy redox balance. So that's what we want to focus on in terms of prevention and staying well, as opposed to waiting till we have a decline and then maybe taking some drug like Premarin or Provera from a physician, which is really not a hormone. It's a chemical that looks like a hormone, but it's really a pharmaceutical drug that has to be metabolized, and it doesn't do all of what we'd like, and it can lead to side effects such as blood clots, heart attacks, and strokes. So to avoid that need, maybe we could focus on helping restore an imbalance. And how are we going to do that? We got to get down to the cell level. So at the cell level, we want to help with mitochondrial damage. So how can we do that? Well, these little mitochondria love redox molecules. They need them. They make them, but they don't always make them in balance, and they don't make enough. So what if we could just infuse an outside resource of these little molecules from supplementing them? It is now possible to drink stabilized redox molecules. Mitochondria love them. Next, oxidative stress, the buildup of rust. Cells get a little rusty, and it's wonderful to help the cell kind of stop that by giving it a balanced resource, and it will take and pick the molecules it wants, put them to work, and restore the balance so that the cell can repair itself and replace itself and actually work, like in this case, to produce estrogen. And lastly, apoptosis, which is cell death, or senescence, which is cell decline. All of those things happen when there is persistence of imbalance, and eventually the cell will give way. So I hope this is helpful. This is a very complicated topic. Many organs are involved in the production and use of our sex hormones, but in fundamentals, our brain directs our end organs to produce these hormones in proper balance, and the cell's ability to produce them depends on the internal health of that cell. And that revolves around the ability of the mitochondria to produce the things that the cell needs so it can do the work. And if that work doesn't get done properly, then we need to go back to the deepest place we can work at, which is inside that cell at a molecular level to assist the mitochondria and protect the nucleus. So I hope that helps you. There's a great study in the Longevity and Health Span in 2014, February 5th, which kind of gives a nice review of this sort of thing. Feel free to check our reference at the video guide for this series as well. Thanks for attending. We'll see you at the next lecture.